So in this problem we're told to evaluate the integral from 1 to 64 of 4 plus the cube root of x over the square root of x dx. Let's start off by just rewriting it. So 1 to 64 of 4 plus the cube root of x over the square root of x. So what we got to do is simplify this top. So how do we go about doing that? So I'm going to rewrite it as 4 over the square root of x plus the cube root of x over the square root of x, right? Because you can do that. And then what you got to realize is that we can simplify this even further. So 4 is the same thing as 4x to the 0, right? Because x to the 0 is just 1, and we multiply by 4 is just 4. And then the square root of x is the same thing as x to the 1/2. And so writing it in this form is going to make it easier to simplify. So the exponent rule tells us that if we have a base, the same base to exponents, we can rewrite it as x to our top exponent minus the bottom one. So it's going to be x to the 0 minus 1/2. Then we're multiplying by 4, right? But 0 minus 1/2 is going to be minus 1/2. Then times 4 is 4x to the minus 1/2. So all we did was rewrite this part right here. So 4x to the minus 1/2, and then plus, and then let's simplify this one. So it's the same thing as x to the 1 over 3. Then we divide by the square root of x. So that's just x to the 1/2. So this is going to become x to the 1 over 3 minus 1/2. So our top minus our bottom. And then we're going to simplify this, right? So we can make these over 6. So 1 over 3, we want it to be over 6 instead. It's going to be 2 over 6. 1/2, we want to put it over something over 6. It's going to be 3 over 6. So this is just going to become minus 1 over 6. So we just rewrote this as x to the minus 1 over 6. So let me rewrite the integral. So 1 to 64 of this, we basically just rewrote this whole thing into this. And then we multiply it by dx. I forgot to put the dx here too. But now what we got to do is find the antiderivative of this. So let's go ahead and do that. The antiderivative of 4x to the 1/2, or to the minus 1/2. What we do is we add 1. So it's going to be x to the 1/2, right? It's minus 1/2 plus 1, 1/2. We divide by our new exponent, and then multiply by our constant. So 4 divided by 1/2 is going to be 8. Then it's just 8 times x to the 1/2. So it's just 8x to the 1/2. Plus, so we got to take the antiderivative of x to minus 1 over 6. What we do is we add 1. So minus 1 over 6 plus 1 is going to be 5 over 6. Divide by 5 over 6. Dividing by a fraction is just going to be the inverse of it, multiplying. So it's just going to be 6 over 5 times x to the 5 over 6. So 6 over 5 times x to the 5 over 6. So this is going to be the antiderivative of that. Then we want to evaluate it at 64 and then subtract whatever it is at 1. So basically we plug this in, get a value minus whatever this value is. So plug in 64, 8 times 64 to the 1/2 plus 6 over 5 times 64 to the 5 over 6. So 64 to the 1/2 is the same thing as the square root of 64. Square root of 64 is going to be 8. So it's 8 times 8, which is just 64. So we have 64 plus, then let's solve this part right here. So 64 to the 5 over 6 is going to be 32. And then we just multiply 32 by 6 over 5. So that should give you 38.4. So we have 64 plus 38.4. Go ahead and do that. You should get 102.4. So when we plug in 64, we get 102.4. So let's write that right here. And now what we got to do is plug in 1. We're going to subtract that value from 102.4. So if we plug in 1, it's going to be 8 times 1 to the 1/2 plus 6 over 5 times 1 to the 5 over 6. 1 to the 1/2 is just 1 times 8 is 8 plus 1 to the 5 over 6 is just 1, times 6 over 5 is just 6 over 5. So 8 plus 6 divided by 5 is going to give you 9.2. So what we got to do is subtract 102.4 minus 9.2. So if you go ahead and do that, you should get 93.2. So this right here is going to be our answer. So the answer to this problem is 93.2.